Okay.
Non sono io l'organizzatore. Ok, adesso la riunione è anche registrata.
Okay, so let's switch to English.
Yes.
Let's switch to English.
Someone asked for the registration of the... Okay.
Okay, very good. I think we will start with my short introduction of a speaker who probably does not need to be introduced because he is very famous, particularly on these topics that he will be lecturing to us because he will be speaking to us about sustainable energy transition and overview. Professor Marzio Galeotti, whom I have the honor to have known for several decades, is now professor of environmental and energy economics at the University of Milan. He holds an MPhil and a PhD in economics from New York University. He was the founder and the first president of the Italian Association of Environmental and Resource Economists. He has been an expert reviewer of the Intergovernmental Panel on Climate Change, the famous IPCC, and the coordinator of the Climate Change Modeling and Policy Research Program of the important research foundation Fondazione Enrico Mattei in Milan. He has published extensively and in scholarly journals and with international publishers, and actively participates to the policy debates through media interviews, comments, and articles in newspapers and magazines, and speeches and presentations in non-academic public events. Today, he will speak for between 30 minutes and 40 minutes, I suppose. And then we will have a question and answer session. Professor Galeotti is very well known also in at world level, particularly in the last few years. He has been partnering with important institutions in the Arab world, and he has been doing lots of publications. His activities are, he's very active still in research, and so I don't want to waste our time and his time, which is very precious, and I invite Professor Galeotti to start his seminar, his presentation. Marzio, the floor is yours.
Thank you very much. Good morning to everybody. It is a pleasure to having been invited to give a talk here. And it is also a pleasure to have been invited by a good friend and colleague, Nan Giovanni Ferri. I used to call him Nane because we have been friends for a long time. We also share, if I can reveal it, the future, because we feel towards sustainability at some point. And ahead of the fact that sustainability is now the dominant issue in the international affairs. But having said that, I'm also pleased because the audience I'm talking to comes from regions with which I have some familiarity, because I've been visiting Saudi Arabia.
Marzio, we can hear you only now and then. Can you please bring your mic closer to your mouth?
Like this?
Let's try.
I was saying that, is it better?
It is coming and going. Can you try? Would you want to try without headphones? Maybe the headphones are...
I thought it was better, but let me find out. Can you hear me? Can you hear me now?
Much better, thank you.
Much better. Okay, sorry about that. Sorry about the technology. I thought it was an improvement, but it was not. I was saying that it is also a pleasure to talk to people who come from a region with which I have some familiarity, because I've been visiting an international research center in Saudi Arabia for the last 3 years. And I've been in touch with you know, people issues and concerning the energy, environmental, and economic aspects of some of those regions. But as was requested, my talk will be, you know, we'll have a global view, not a local or a regional one. And I was requested to talk about the sustainable energy transition. And I took literally the title, because I will be talking briefly about what is a transition and energy, why energy, and what we mean, or we're supposed to mean by sustainable. So let me start my talk by sharing my screen. I hope you can see it. Let me see. Can you see it?
Yes, we can.
Yes.
Okay. Let me put the full screen. Is it good?
Yes.
Good morning.
Okay.
Yes, it's good.
So that's the title of this presentation, and I will start immediately with an outline just to give you an idea of what are the main aspects that I want to touch upon. First of all, we would like to briefly define what is the energy transition, a term everybody is talking about these days, together with some other keywords like decarbonization, net zero emissions, and the like. What is the second point is that I want to briefly illustrate what we mean by energy systems. And thirdly, I want to argue that there is not a single energy transition, but there are many. And in the history, in the past history, there have been more than one energy transition. But this time, there is something different. And the difference with respect to the previous transitions has to do with this word, decarbonization. But what we mean by decarbonization? I will very briefly, at the cost of saying something that is probably very familiar to everybody, briefly mention a few aspects, key aspects of the climate change problem, of the climate change issue. Just to then focus on what is implied by energy or transitions, or what an energy transition implies. And I picked in particular an illustration of the so-called net zero emissions scenario. I don't know whether some of you is familiar with this, but recently the International Energy Agency, together with some other research center of oil companies, have been looking at scenarios entailing going to zero emissions at some point in time, and what that implies and what that means, in particular in terms of costs and benefits of this huge transition. I will conclude with some open questions. So this is my outline, and then I will start by trying to define very simply what is an energy transition. Is a change, presumably radical, significant, not just a small change, from one state, the current state, to a new one. And the attribute energy means that the change I'm talking about refers to the change in the energy system. So we are moving from the current energy system. Obviously, there are many energy systems. Each country has an energy system that may differ from that of another country. But, you know, with the global view, I can talk about the energy system, and the transition entails moving to a new one. And the new one has, or we want it to be sustainable. It is more complicated to define precisely what sustainability, what we mean by sustainability. It's a more evanescent concept, because many people talk about sustainability with alluding to different aspects of it. Okay, roughly speaking, we can say that it refers to an environment-friendly change, or we are moving toward an environmentally friendly new state or new energy system. And because we are talking about energy, this environmental friendly situation obviously refers to climate change, to greenhouse gas emissions that are released by certain sources of energy. And the climate system being environmental friendly means that is not affected, is not incurring the alterations that we are observing right now due to human activities and the interference of human activities with nature. Okay, so that is my definition of the title and of the topic that I want to touch upon briefly. So let me spend 2 words on the issue of energy and energy system by reminding ourselves, all of us, that energy as a fundamental dimension is the engine of economic growth, and therefore is the way to deliver prosperity to people, to society, to individuals. Not forgetting that there are a few aspects that are important and are related to prosperity and economic growth, which is, let us remember the one dimension of poverty is energy poverty, the lack of access to energy. And another important dimension is the ability to access energy sources, so the issue of security of supply and energy dependency. The third aspect are the environmental implications of the use of energy as we currently use it or make it, have it. Key elements of when we talk about energy: the sources, the so-called primary sources, the technologies, and the markets, because the ultimate goal is to deliver to individuals energy services like lighting, heating, cooking, and so on, which are the output, if you want, of a transformation process that entails the use of certain technologies and as inputs certain energy sources. So an energy system, roughly speaking, is made up of these aspects. And energy sources can be either, but I'm saying things that are familiar, I'm sure, so I will be very brief. They can either depletable or exhaustible. They are still dominant right now. In particular, fossil fuels, about 80% of the energy sources globally in use nowadays. The other type of energy sources are the so-called renewables. They are becoming increasingly important for environmental reasons, okay? These 2 types of resources have different characteristics that you see listed here, but I will, in order not to gain some time, I will skip it. So the energy system entails basically the use of primary energy sources. And here is the list of the main ones: coal, oil, and natural gas, the fossil fuels, plus hydro, the main renewable resource worldwide today. Other renewables, solar and wind in particular, also nuclear. And this primary nuclear, by obviously I mean the uranium, which are energy sources that enter a process of conversion through appropriate technology to generate what are called secondary energy sources or vectors, like fuels for transportation, electricity for domestic purposes or for industrial purposes or commercial purposes. So the final use of energy is with a sectoral breakdown represented on your right-hand side. I will not spend time illustrating this chart here. I will leave it with you, but basically it gives you a few examples of what I just mentioned. So, for instance, in the case of a fossil fuel, say gas, we go from the process of extracting it from the underground and treat it, then convert it to for commercial use, to distribute it until it reaches the final users, okay, and serve certain purposes like cooking or heating a house. And so you see that, as I said before, the combination of conversion technologies and primary sources delivers the final output, energy services. So when we talk about energy transition, is a change in the structure of this energy system that you see represented in front of you. This just gives you an idea of the current flows. It refers to 2012 globally in terms of relevance, quantitative relevance of the various primary sources and where they end up to. Okay, so I just without not making too many comments, you see that oil nowadays largely serves the purpose of transportation, okay, or used in industry, say the petrochemical industry or the chemical industry, okay, whereas coal is largely used for generating electricity. So this is a snapshot of what are the main flows of energy nowadays. So talking about, the energy transition, now we have seen that it entails a change in the energy system. We can note that in history, humans did or went through many energy transitions or determined many energy transitions that were producing fire a long time ago, domesticating animals in order to have or exploit animal energy, or domesticating wind. Think of sailing and windmills, or domesticating rivers for similar reasons, and also transportation. So an energy transition is a change in the energy system where very often you shift in the use of primary energy sources from a dominant or a few ones to a new ones, okay? Sorry. An energy transition, as I said, is gradual, takes time, but typically is radical. Is not just a gradual, a small or incremental change. And so today's energy transition entails moving away from the 80% of total fossil fuel as primary sources that we are using in the global energy mix. Okay? But obviously, as I said, many energy transitions occurred, and they were characterized by different degrees of penetration, different times or speed of the transition. And here is an example of what the situation was and what it is now. Let me first consider the chart on your right-hand side. This shows the primary energy sources from 1800 to today. And as you see, there has been an increase, at some point, an increasing use of fossil fuels, a massive increase, coal, oil, and then also natural gas. Renewables are just starting to become more important, and only recently. Whereas traditional biomass, which were the dominant energy source until, say, 1850, nowadays are, relatively of little importance. But at that time, they were the dominant source. And when we talk about traditional biomass, we should think of wood specifically or in particular. So as you see, the percentage in your energy mix, the share of primary energy consumption on the total
if you look at time, you can see what happened for, say wood, for instance, from 70% went down or has gone down to almost to negligible amounts. We have seen an increase, massive increase of coal, which has been then diminishing after the 1950 because it has given room to oil, which has become more and more important. Why? Because of characteristics and features of these energy sources, given the use that we wanted to make. So, for instance, the increasing penetration of transportation of the combustion engine called for an increased use of oil. This is a famous paper or contribution by Václav Smil, who has studied, a scientist who has studied many energy transitions of the past. And he has been noting that usually an energy transition takes a lot of time. Not all of them take time, but for instance, if you see this quotation, he's noting that the penetration of new renewables right now is not especially rapid if you compare it with the penetration of fossil fuels in previous or past energy transitions. For instance, coal was gaining importance at a rate of more than 5% a year between 1850 and 1870, around 20 years. Oil, similarly, also natural gas. So this is important to keep in mind, okay? Because the change is different. And this time, the energy transition toward, away from fossil fuels and toward renewable sources for environmental reasons is becoming more complicated also by the fact that in the meantime, given the increasing incomes and population, the amount of use of energy relative to this value here, 1,500 megatons of oil equivalent in 1919 has gone up to 14,300, all right? So now there is also, in addition to that, the challenge is also one of scale. We need to move away from fossil fuels, but taking into account that there is an increasing use of total energy. So a new energy transition is underway, and that consists of a substitution of fossil fuels, okay, with renewable energy sources that are gradually phasing in. This time is not the introduction of new energy sources, the discovery, if you want, or the invention of new technologies like the combustion engine that implies or drives the increasing use of certain sources, which then increase their share in the global energy mix. This time, it is the increasing threat posed by climate change and the risk of big damages that is bringing about the necessity to move away from the use of fossil fuel, which is the dominant type of energy source today, and the need to reduce greenhouse gas emissions that are released by their combustion. Why is this necessary? Then let's see. And in saying this, I want to briefly mention a few important aspects to fix ideas concerning climate change. We can think of a situation of what is called global warming or the atmosphere as a bathtub, okay? Where some water gets in and some water gets out. The water that goes out, there is water in the bathtub. And so you should think of yourself at the end of a long and tiring day to take a nice a bath in order to relax. And so you enter the tub and you have this water coming in, but this water is hot. And the hotter it is, the higher the average temperature of the water in the bathtub increases, okay? The hotter it is. So what was supposed to be a nice and relaxing bath becomes very uncomfortable. And that is the case of our atmosphere, because we are pouring, so to speak, increasing emissions of fossil fuels from burning fossil fuels that are not enough absorbed by the so-called natural sinks, oceans and forests on the other hand, with the result that we have an increasingly hot atmosphere. So here is the story to put some economics in it, okay? And where do we start? Well, we can start from GDP. The production, as we know, is the amount of goods and services that are produced by an economic system. Presumably, there is some debate about it, but I will not enter that. The more goods and services are available, the higher is our welfare. So more economic growth entails more prosperity, but economic growth entails the production of goods using certain inputs like capital and labor, the other inputs, land, if you want, or soil, and in particular, energy sources. These energy sources we have seen can be either renewables and fossil fuels. To the extent that we use fossil fuels, we generate greenhouse gas emissions, which accumulate in the atmosphere, adding to previous emissions, and therefore determining an increase in greenhouse gas concentrations. And it is the increased concentration that prompt alterations in the current climate system that determine a thermodynamic response, entailing increasing temperature and other climate alterations. And these alterations in climates bring about the so-called climate impacts or damages that inevitably feedback or, act as a backlash to our own activity, because they influence directly our own welfare or affect our ability to generate, enough economic activities. We have seen sinks, I just mentioned them, they took out some emissions so that they control to some extent concentrations. The other two elements in this chart are the type of climate policies that we can put in place in order to try to control this process. And these are mitigation policies like carbon taxes, which aim to reduce emissions where they are generated. Okay, so they want to cure the problem where it originates. And on the other hand, we have adaptation measures, which simply take into account or take for granted that there has been an increase or climate alterations. And these adaptation measures only aim to reduce the negative repercussions on individuals or on nature, on the planet, of these increasing damages. So let me give you an example. To install an air conditioner in your room is an adaptation measure. This is an example of adaptation measure because it is hot and it remains hot outside, but we reduce the impact on our body, all right? So if there is an increase in sea level, which threatens the flooding, huge urban settlements to resettle this huge population is another huge, again, I use again this term, example of adaptation measure, obviously very costly, as you can imagine. So the first thing is emissions and energy. Here is just to give you these charts, just to give you a glimpse of the situation or historically. You see that basically it has been an increase in the use of fossil fuels, the chart that you see right in the center in front of you, that has given rise to an increase in corresponding increase in emissions. Okay, the chart on your left-hand side. And you see also which are the countries that have been historically more responsible, traditionally Europe, then even more so United States, more recently, largely China and other Asian Pacific countries, including India. The historical behavior of total emissions is on the right-hand side chart, which I put here because it starts from 1900, and you see also the impact of COVID, that little red dot, together with some small temporary decrease due to certain global shocks like the financial crisis in 2008, 2009, but then emissions recovered and they went up again. And you know, the initial signs of the behavior of emissions shows that the recovery after the COVID or the current recovery is bringing emissions up again. So these emissions prompt a number of alterations, as I said, in the climate system, including global warming temperature, but also sea and ocean level rises, acidification of oceans responsible for the death or the bleaching of the coral, of the Pacific coral, the reduction in the ice cover, especially in the Arctic, or the snow cover on the alpine territories, a change in the patterns of rainfalls and precipitations, and increasing droughts and desertification, and increasing the intensity, the power, and the frequency of extreme events like cyclones, hurricanes, typhoons, tornadoes. We have seen recent examples, fires, heat waves, and much more. So the outlook is not especially good, and these climate change alterations determine impacts that affect the agriculture and food security, ecosystems, both terrestrial and freshwater, coastal zones and marine ecosystems, human settlements, insurance and financial services. Insurance industry was the first one to fund the research on climate change, as you can imagine, health and healthcare systems, even national security, because conflicts can break out because, you know, disagreement or fight for the availability of water resources that are depleting due to the warming of the planet. Europe in particular is going to be affected by reduction in snow cover, alteration in precipitation, impacts on agriculture, on forests, and fishing. What is important to remember is that these damages or impacts, to the extent that are avoided, can be qualified as benefits from climate policy. So the purpose of a climate policy is to avoid these damages, okay? And every action that avoids these damages therefore generates benefits to society. But what is important to remember is damages are differentiated across the globe, both across sectors. They do not affect sectors of activity in the same way, do not affect the world regions in the same way, and the map you have in front of you is pretty, you know, clear and evident. And the third aspect that is, you know, is one of the main tasks of climate economists is to attribute a monetary dimension to the damage assessment, because without a firm, you know, as precise as possible quantification of costs and benefits of climate change and of climate policies is difficult, you know, to inform policymakers.
Sorry, Marzio. If you can go back to the previous map, since we have people from Lebanon, Tunisia, and Egypt, and it is kind of difficult to distinguish whether their countries are medium or high in the map. Since you have the source, maybe later, can you specify how is the situation for their countries?
For their countries, well, I think I can reply saying that in general, the situation of climate damages for, you know, the MENA countries is a serious one. The most problematic areas are the sub-Saharan African countries, which is the most vulnerable and at the same time the least responsible for what is happening. But still, mostly because of, you know, aspects concerning the water availability, and agriculture, countries like Tunisia, like Lebanon, and like Egypt are seriously affected. You can see the map is high level of damage estimated by you know, in this chart, and this chart refers to the work of the IPCC, the Intergovernmental Panel on Climate Change. Okay, I don't know if it is enough, but we can come back later.
Thank you.
So I was saying that the other important feature that you need to bear in mind when thinking of climate change is the fact that it is a long-term phenomenon. Most of the damages are not the one we're starting to see now, but will take place quite far in the future, toward the end of this century and beyond. So they will affect mostly future generations, okay? And very long-term damages. And because it is very far in the future, a lot of uncertainty is associated with these events and with these damages. Our knowledge, because we look into the future, even scientific knowledge is not, you know, enough given the uncertainty. Even climatologists are, you know, striving to understand more and more of the patterns and changes of the climate system. Let me remind you that the climatology refers to slow, long-term changes in the climate system, whereas meteorology refers to very short-term changes in the climate system. And because changes in the climate system are very slow to take place, we cannot observe them, we cannot replicate them in a lab. So that we, as they say, we are living in a global currently we are living in a global experiment, okay? So a lot of uncertainty is attached to the damages we have seen. And just to give you an idea of the possibility, perhaps with the low probability, but with a high level of damage, here is this example, that is the increase in sea level rise that may threaten or may flood regions in the worst case scenario, regions that you see here largely affect, you know, Belgium, the Netherlands, and water we get almost to London. And probably some of you has seen the movie The Day After Tomorrow, where there is this big cruise ship entering Fifth Avenue in Manhattan because the level of sea has flooded completely the island. The third aspect, before moving to other issues, has to do with the monetary valuation of the damages. In the aggregate, we would like to know what is the cost in terms of GDP of all the damages due to warming if we do nothing. And here you see a range of estimates taken from the literature. There is a lot of uncertainty, as I just mentioned, but obviously the question is, when should we start acting? When it is too late? Where should we stop in order to prevent further warming? The famous book or study 2007 study called the Stern Review that you see here was estimated losses in terms of global GDP up to 20% at the end of this century if we do nothing. Whereas we could avoid these damages or these costs if we invested 2% of GDP every year in aggressive climate damages. And because the cost and benefits balance is clear, the recipe of the Stern Review was we should act immediately, especially if there are low probability, high impact events. The precautionary principle, according to which we should act immediately to be conservative and to avoid the possibility of these huge damages should apply. Obviously, many countries, many policymakers, many people, many individuals perceive the climate policy and the need to reduce emissions that should bring about, the benefits that I just mentioned as a threat to economic growth and the possibility of increasing prosperity as we are witnessing historically for the last several years in many countries. And as you see, the dilemma here, or what is presumed to be a dilemma, entails the fact that increasing GDP, look at world GDP over the last 2 millennia on the right-hand side, determining an increased use of energy, coupled with an increased population, putting more pressure on the planet, have determined a dramatic increase in CO2 emissions. So it seems that the only way to reduce emissions is either to stop population growth and or stop economic growth. And this is a minority view, but most of the climate economists believe that it is possible to decouple, as we say, the dynamics or the trends in CO2 emissions from the trends of GDP. And if you look at the chart for the world, starting from 71, you see that according to historical data, that has been possible. Where is the problem here? The problem is that the coupling is not enough. We need to bring down emissions, not to reduce the speed of increase relative to GDP. So we need to do more, all right? So we need to move from a relative decoupling to an absolute decoupling. Is it possible? Well, as I said, the answer is given by science, and the policy response, science says we should stop as much as possible, as soon as possible, emissions. The policy response has been, the energy transition, move away from fossil fuels, limit temperature increase, stabilize carbon concentrations. And the way to do or know where to go and how to do it relies on scenario analysis. When it comes informed by scenario analysis, then the policy response should be international agreements like the Glasgow COP26 meeting that is going to take place this November, where there are high expectations, or the Paris Agreement. In other words, international policies or agreements on policies designed or finalized to curb CO2 emissions through appropriate uses. The policy response has been, roughly speaking, at the international level, the one that you see reported here. I don't want to spend time here because time is running faster than I would want. But basically, there are a few milestones, like the release or the definition of sustainable development with the Brundtland report in '87. In '92, we have the first international summit devoted to climate change. In 1997, we have the first international agreement to reduce emissions signed in Kyoto, the Kyoto Protocol. More importantly is the Paris Agreement in 2015. This is the currently the current international agreement on climate change that is still operational, underway these days. Here you have some important dates, but I will let you have a look when you see this chart. So science, the IPCC says that we should, in order not to see a change in our usual economic and social activities, the ones we are used to, okay? We should try to limit the increase of global temperature to 1.5, 2 degrees relative to pre-industrial levels. End of the 1700s and mid 1800s, okay? So if we are able to keep that within that limit, then probably we do not have a complete, change, and we do not enter uncharted territory. The more recent report was a special report released in 2018 by the IPCC, was noting the global warming is increasing or progressing faster than we thought. So it recommended to, as a precaution, to keep temperature increase to 1.5. And related to that, in order to ensure that the temperature would not go beyond that level by the end of the century, it's suggested to go to zero net emissions by 2050, what is sometimes referred to carbon or climate neutrality. The two things are not the same, but I will not elaborate upon that. Why net emissions? Because that means that for 1 ton of emissions that you put up in the atmosphere, you should reduce correspondingly or trap it, or trap 1 ton of emission through deforestation or through other ways, so that the net balance is zero by 2050, okay? Relative to the previous report in 2014, so we are now suggesting to be stricter and faster and more effective climate policy. The response of politics was the Paris Agreement, and we know what the Paris Agreement is. Signed by almost all countries in the world. The final target is to do everything well to keep temperature from increasing to +2°C, or do as much as possible, or all effort to contain the increase to 1.5. Quick ratification. The problem is that they are, unlike the Kyoto Protocol, there are pledges, not binding targets. So, in other words, a country is not forced by an international agreement with some penalty and so on to do what it claims it will do, okay? To some extent, that explains why many countries have signed this Paris Agreement, but that what is available nowadays is what is served on the international table, and we have to stay with it. Obviously, the initial round of pledges, the so-called national determined contributions, implied a warming that is way beyond 1.5 or 2. Is between 2.7 and 3.5 according to estimates. So we need to make it stricter, and that is calling for a new round of pledges, and Glasgow is precisely the place where countries will reveal or announce more strict or more ambitious climate policies, in national climate policies. Obviously, because the target or the goal is to reduce emissions to net zero, as you see here. I think I need to accelerate my talk because time is, how much time do we have? Not much. I'm already in the red zone. Anyway, so the new mantra is net zero emissions, okay? And according to estimates, 59 countries have announced or communicated these net zero pledges, and over 130 countries have stated that are considering or have already decided to go to net zero by 2050. So in the last year, we have seen an increase, round of statement in this direction, starting obviously with the European Union, with the new Commission, with Ursula von der Leyen, which has put at the center of the European action, the EU action, exactly the fight to climate change. And the climate neutrality by 2050 is today enshrined in a European climate law. So it is given a lot of strength from, a legal and also political point of view. And after this climate law, which is the most important component of the so-called European Green Deal, there have been other announcements. The most important ones by China in September. Xi Jinping, somewhat surprisingly, stated that China aims to go neutral by 2060. This sounds or seems currently as a contradiction, as they keep installing or building new coal power plants. Although I read a statement, I think yesterday, made at the UN meeting by Xi Jinping again, who claimed or who stated that China is going to stop the building of new coal-fired power plant. We will see. And then after Trump, we have the US, which is back on the climate table, and President Biden has announced a $2 trillion climate plan, and is considering also a climate neutrality goal. So net zero has become the new reference. And the International Energy Agency has released a visionary report that is informing us on what? Well, precisely what it means. Because now we have a deadline, 2050, we have a quantity, zero net, okay? But obviously there are several ways and changes in the energy systems to get there. And so the IEA has been suggesting one way, and because it is very authoritative as an organization and as a report, everybody has been talking about, what this means. So now let me show you a few charts of what that means. It means going down to zero in terms of CO2 emissions, and that entails a dramatic change in the use of primary energy sources. In particular, we have to phase out completely coal and reduce significantly the use of natural gas and oil, according to the IEA, with a massive penetration and increase in renewable energy. Mind you, we are talking about globally, but whereas the use or penetration of renewables, perhaps in Europe or European countries, is important and significant, that is not so in some other parts of the world. Okay, this change will bring about a reduction in the oil supply. Nowadays, we are using about 90 million barrels per day. In the new net zero emission, it will go down to 20. And that has somewhat scared oil producing countries. Well, not somewhat. At the same time, new technologies, especially renewables, will call for an increasing demand of minerals and certain key raw materials, with the shortage of which in America and in the European Union is already being felt. New clean technologies will need to be installed, especially when it comes to solar and wind, okay, to produce increasing quantities of electricity to, make electric cars and vehicles move around, see the increased sales from 2020 to 2030, 18 times. So you see the dimension of the change, right? And here is the report by the Renewable Energy Agency. I'm okay. Just keep in mind that this 36.5 gigatons of CO2, which is the amount of emissions now, okay, which we need to eliminate, to bring down to zero. And according to the IRENA, the way to do it is in 3 ways. An increase in energy efficiency, that is reduction of energy per unit or per dollar of GDP, okay? So new technologies to conserve and better and more efficiently use energy to produce the same things. Second, an increased penetration of renewables, especially for electricity purposes, but not only, okay? And third, an increased electrification of everything. So in the future, we will be heating our housing with electricity, okay? We will be doing many things with the use of electricity, obviously generated from renewable sources. And then let me draw your attention on the increasing role of hydrogen, because there are sectors of production like cement, steel, and so on, where you need a very high, extremely high temperatures that can be more efficiently produced by the use by hydrogen as opposed to electricity, or in some instances, electricity cannot be used, like in cement production. So we can foresee an increasing use of hydrogen. In the developed world, but not only, for instance, in other countries, governments are adopting hydrogen strategies because they are seeing that hydrogen is going to become extremely important in the new energy system during the energy transition. And there is a debate right now between the so-called green hydrogen produced with electrolysis, that is, water and the use of renewable sources, which has zero emissions implications, and the so-called blue or gray hydrogen, which is steam reforming technologies, which use natural gas. Depending on whether the CO2 generated by the burning natural gas or the use of natural gas, is trapped or not, you have the distinction between gray and blue hydrogen. Gray hydrogen obviously has a CO2, a climate change impact that blue hydrogen and green hydrogen. Hello? I see somebody who has not muted himself or herself. In any case, let me show you, this is quite effective because relative to today, in 2050, the new energy system will change dramatically. Look at the role of electricity or direct electricity, 51% against 21. Oil down to 4% relative to 37% today. Coal basically eliminated, okay? Increased role of modern biomass and hydrogen as well. This is very important, very significant, because it gives you the idea of the challenge we are facing. That entails a lot of money or financial resources that need to be mobilized. And, as you see here, the 2019 is the current situation. If we do nothing, PES is the scenario where we basically adopt the current policies that are not enough relative to the policies necessary or intervention and changes relative to the 1.5 degrees scenario, which is the one that you see on the right-hand side. And as you see, one important aspect is that we need not only public funds, but also private money, the intervention of the private sector, without which not enough, this thing would not be possible. But investors and financial markets, Giovanni is an expert of these issues. Investors and financial markets are anticipating the energy transition because they look ahead, they understand what is coming around, what is going to come around, and are already allocating capital into companies or uses that do not involve the use of fossil fuels and toward energy transition technologies such as renewables. So you see here on the right-hand side, green bonds, green loans. There has been a significant increase in the green bond issues. On the right-hand side, you see the performance of the stock index referred to clean energy as opposed to just energy in the Standard & Poor's 500. Larry Fink is the CEO of BlackRock, one of the largest, or the largest, I think, investment fund, who has been known to be, you know, the foreman or at the forefront of this drive towards sustainability. Today is the top issue for investors, has been reported to state. What are the benefits? Now I'm going to accelerate. And let me just state that every $1 spent on energy transition should yield between $2 and $5, according to IRENA. Where do they come from? Well, they come from energy savings and from avoided damages from climate change, appropriately monetized. Let me just stay with this. But in terms of differences in GDP relative to a business as usual scenario, I invite you to look at the solid red or violet line here, where you see that the difference is, in terms of GDP, especially in the first decades, is going to be significant and remains positive. Okay, even more so if you take into account climate damages relative to the case or to a scenario where no climate damages are considered. And obviously, something we are all interested and sensitive to is what does that imply in terms of employment, jobs, okay? And looking at energy sector, so not all employment, the energy transition is going to produce an increase in sectoral jobs, You see here in the higher bar of this graph on the left-hand side, okay, broken down by types of sources or broken down in terms of stages of production of the value chain, okay, especially manufacturing, fuel supply, and so on. This is where most of the employment will come from. But at this point, it's time for me to stop. And I want to stop with mentioning just a few remaining questions. It is clear by now, I'm sure, that the magnitude of the challenge is dramatic, is enormous, okay? There are a few questions that, you know, I leave with a question mark and I will not address. But one is, I've been talking about the energy transition with a global view. But obviously countries differ in terms of energy mix, in terms of per capita GDP, in terms of many aspects, not only between producing developing countries and emerging countries, but even from the point of view of the fact that there are big consumers and big producers. So there will be many energy transitions, not only one. So every country will have a look at its own goal, modernizing and diversifying the economy, improving energy security, reducing energy dependency, energy access, mitigating climate change, and so on. Are evident or are apparent if you think of the G20 group. Okay, this year Italy has been chairing the G20 group, you know, the climate change has been top on the agenda of the G20, where countries that are represented there are the most important from an either an economic and or political point of view, but differ very much in terms of energy mixes. And even the Paris Agreement pledges differ from this point of view. So what will be the final outcome will depend also on these several energy transition. Confronted with the net zero emissions and the IEA report, for instance, Australia was quick to state that, I'm quoting the Australian Minister of Resources and Water, coal, oil, and gas will continue to be a big part of Australia energy mixes. So you see that, you know, some countries are reluctant or more reluctant. Even Norway, which has a lot of hydroelectricity, a lot of renewables, but at the same time extracts oil and sells it on the international market, according to the Minister of Petroleum and Energy, stated that it would not make a difference from a global perspective if Norway stopped its oil activities, which is a bit laughable, if I can say. There will be geopolitical changes because, you know, the big fossil fuel producers today will have to look for alternative ways of producing prosperity for their own people. Let me mention here an example of with which probably many of you are familiar. That is Prince Salman of Saudi Arabia, which has introduced the so-called huge plan, called Vision 2030 plan, according to which he plans or he wants to transform the Saudi economy and society toward a new situation with a reduced dependence of on the receipts from oil exports and increased manufacturing. He has opened up to tourism and so on. So he foresees a transformation in the economy that may be brought about by this energy transition we have been talking about. Renewables will be better distributed all over the world. And that is another important aspect that perhaps, or for instance, is important also for your own countries or for your region, which has, you know, conditions for an increasing relevance of renewables. Renewables will also imply more decentralized energy systems and energy communities. So changes are going to be brought about even in the industry. We will see transportation. Everybody talks about, you know, all transportation being electric, but remember, what about aviation? What about shipping, maritime transportation? These are also important aspects because all, you know, goods and all trade, large chunk of trade goes by ship, okay? And so the type of energy that these ships or the type of engines we will use in the new situation will imply important changes. And I already talked about the penetration of hydrogen. Still, barriers and obstacles remains, okay? Because, as I said, climate change is a very long perspective. It will affect mostly future generations, but decisions are to be taken now. A news lasts a few hours or one day. An electoral cycle or a political cycle lasts like 4 or 5 years. Damages and changes in climate entail centuries. So you see that the dimension of the challenge is very big and entails or takes an important dose of intergenerational altruism in order to be effective against climate change. One important aspect is also disinformation. Remember what Trump was saying about climate change. It was an hoax invented by China. At the same time, it is important also the preparation of the ruling class, because a large portion of the ruling class, not only the political one, but also managers or small size firm entrepreneurs, are largely unprepared to the challenge ahead. So we have, you know, as I said, a number of obstacles, but, you know, the resolution slowly, the uncertainty is resolving, okay? We are increasingly, there is an increased perception by the public opinions and even the policymakers and the decision makers of what are the damages from climate change. And we know that quite well by now. So an increasing awareness by the public, an increasing awareness of the inevitability of policy intervention. Finance has understood this before, well before industry, that sooner or later policy interventions will become necessary, obviously with an eye to the distributed aspects. Okay, because you know, these damages sorry, climate policies will affect in a different way people depending on their income. So we need to mitigate the impact of climate policy on low-income communities and people. That is very important. Otherwise, the intervention will not be successful. What if it is too late? Well, we cannot know that, okay? And, you know, there are optimists, those who are inevitably optimistic. Some other people are very pessimistic, at the point that they are already conceiving or thinking about last resort technologies, like, you know, dispersing or you know, seeding clouds, or using you know, airplanes to disperse on oceans particles of iron, which is known to absorb CO2 and bring it down to the bottom of the sea. So some last resource technology, because, you know, it might be too late, or maybe it is too late. Let me tell you just one thing. These type of technologies are just being studied. We have no idea of their feasibility, and even more so of their cost. And obviously, a precautionary, a sane precautionary attitude cannot rely on this type of measures. We need to do everything, each one of us, to you know, cooperate, so that we are able to move as quick as possible and bring about to the end this current energy transition. Thank you very much. I finished.
Thank you very much, Professor Galeotti. Thank you, Marzio. It was a great lesson, very inspiring to me, and I guess to all of our audience. The precautionary principle that you repeatedly invoked is very important. We have to be optimistic, but we have to be rationally optimistic. And I guess that probably some mix of different instruments, both in terms of traditional remedies and innovative remedies, can help us reverse the process. As it is clear from your presentation, over the last 200 years, we unleashed from underground a very nasty source of energy, which in moderate quantities would not provide serious damage, but on massive quantities, as we have done over the last 2 centuries, has produced massive damage. And it is almost inspiring to see in the last slide that you presented that one of the new technologies for remedying this situation is putting back the CO2 underground, underground storages for CO2, which is certainly a possibility. It is hard to tell whether it is convenient in economic terms. What is the cost? What will be compared to the benefit? But everything will be rearranged. Your presentation was very inspiring, telling us that nothing will be the same in the next 2 or 3 or 4 decades. And if we do not invert the curve, since it will take so long time, such a long time, as when you have a very big tank, a very big ship, that you want to change the course, it takes very long time. So the prices will have to change, the tax systems will have to change, a lot will have to change, but the most important change is within each of us, and particularly within these people that are attending these classes, these workshops, these seminars. And you are, the future is largely in our own hands. The future is largely in your own hands because we are the previous generation, you are the new generation, and you can be sustainable managers, you can be sustainable entrepreneurs, you can remedy the damage that was done by our generation and the previous generations, not specifically by Professor Galeotti and I. We like to think of ourselves as sustainable people, pro-sustainability people, but our generation undoubtedly left to the future generation, to your generation, less than we received our previous generation. So we violated the Brundtland report requirements of sustainable development. I should not take more time, and I will try to recapitulate for Professor Galeotti the questions that came to the chat. So you don't have to read it from them. I already did this exercise through your presentation. The first came from Arwa Wesmi. Forgive me if my pronunciation is not appropriate. And the question is about the correlation between the level of development of a country against the severity of climate change repercussions on the economy. Is there a correlation between the level of development of the country? And this brings us also to another question, which was suggested by Dalia, and it was supported also by Ella. And it is about how serious is the problem of rich countries moving to developing countries, the most polluting industries, in order to clean the environment at home. I have other questions, but I will raise them later.
Okay, the first one was, if I understand correctly, the correlation between the level of GDP or of a country and the damages. Is that correct?
Yes, yes.
I'm not sure that the question is well posed, or I'm not sure I understand correctly the question, because there is a correlation obviously between the level of GDP and the causes of climate change, in the sense that to the extent that emissions are produced by energy sources that are inputs to GDP, there is a direct correlation. More GDP, more energy used, more emissions, and presumably more damages. But the amount of damages also depends on the vulnerability of the place where these damages take place, okay? So there are countries that are more vulnerable than others. It also depends on the level of, you know, the type of institutions, the level of technologies being used that can be put in place or that are in place that to some extent are able to reduce the impact of the damages of emissions and the damages. On the relationship between energy use and GDP, one important aspect that, you know, on which, you know, energy and environmental economists have been working on is to try to understand, if you remember, there was a chart that I showed you on the so-called decoupling, to understand if, you know, for every 1% increase in GDP, there is a 1% increase, corresponding increase in emissions. Because if that is the case, a country that is developing and growing in terms of GDP will always bring the generate increase in emissions. They will not start decreasing. And the answer is that there is a scale component, the sheer dimension of the economy that for sure entails more energy use, but also and also more emissions, but the type of energy due to intervention of appropriate policy may change, or there can be a substitution in this energy mix by away from fossil fuels and increasing renewables, so that while GDP keeps increasing, the amount of emissions decreases because there is a decrease in share in fossil fuels. So basically, technological change, climate policies, structural changes of the economy. Remember, we in an economic system where there is a heavy industry, other things equal, will produce more emissions than countries where there is a large amount of component of services, because services are known to use, you know, to generate less emissions. So also the structural composition of production and consumption accounts for the ability of, you know, generating fewer emissions and reducing emissions. So I'm not sure whether I answered this aspect here first. The second one was, remind me, Nanni?
It was about what is the extent to which rich countries are transferring polluting technologies and industries to less developed countries.
Okay, this is another important issue because it's sometimes called to, in the literature, economic literature, is sometimes called the race to the bottom, or, you know, environmental dumping. And it consists of the following. In countries where climate policies are put in place that are more severe, will increase the cost of production of certain activities, which will find it convenient to move abroad and to countries where there is a lax or a laxer or even absent climate policy. So that basically you export emissions, okay? This is a phenomenon that in particular has been considered when looking at the role that, or the type of economic growth that has been going on in China. Because in China there are many manufacturing activities, a lot of heavy industries that have been put there also because you know, instead of in countries where there were more aggressive climate policy, I can say that the evidence, the empirical evidence on this is not totally clear, it's not unambiguous, because the reasons why you establish an entire new activity abroad are not due only or simply to environmental reasons. Very often you need to, the reasons are labor or labor cost. So one of the big reasons why many activities went to China is precisely the availability of labor, very often unskilled, that could be used at very low cost. So the conditions that need to be satisfied, where you put, establish new activities, are several. And although there is some evidence that the climate policies are one of these reasons, are not the exclusive one. Okay. In Europe, this aspect these days has given rise to a different type of approach. And the reason is because climate policies for the industries and firms that are operating within the boundaries imply an increasing cost, because the cost of carbon emissions here is increasing. Then there is a so-called unfair competition over similar products in European markets by goods produced elsewhere, especially in China. So the discussion in Europe, one of the main discussions going on in Europe is about establishing the so-called carbon border adjustment mechanism that amounts to a tax on imported goods that have a polluting content that is higher than the ones of equivalent goods produced within the European countries. That's
it. Thank you. Another question which is posed by Jihen Belgasmi is how are the national and regional policies and the evolution of the environmental private sector in the MENA contributing to limit the environmental risks due to climate change? This is a big question. The environmental risks of climate change are not only related to energy, of course, but I would rephrase it in terms of the private sector involvement in the energy transition in the MENA.
So the question has to do what is the role of the private sector in the MENA countries with respect to the energy transition?
Yes, I would rephrase it like this.
I think I do not know enough. Of those countries. I know something, but mostly related to the energy system.
Maybe Jihen can write you an email to ask if you have some.
Perhaps, yeah, but I do not have enough knowledge. But let's see if I can, say something about. It depends really on the country. The country I know better is Saudi Arabia, where there is a private sector that is still small, made of very small firms, but there is a very special regime there. As you know, 2/3 of population are expats. So policies are put in place in order to push the private sector to expand their activities. But it is a country where the role of the government, there is a lot of control by the government. So for instance, energy prices are still administered prices. So they want to increase the degree of political freedom in economic activities, obviously. But there is still a lack of an important entrepreneurial class with the appropriate preparation. Things are changing, but very slowly. That is almost all I can say.
Still regarding the MENA, there is another question about how useful could be nuclear energy.
Well, nuclear energy is a very controversial issue, as we all know. Even recently in Europe and in Italy in particular, there has been a new surge of the debate that is a recurring debate about nuclear energy. Also because there have been recent advances, discoveries actually. I don't know whether you are familiar with the fact that there has been some significant progress undertaken by MIT researchers on the fusion, nuclear fusion front. Okay, right now we are talking about nuclear fission is the current and the dominant technology. Now, as you know, basically in Europe, nuclear energy has been phased out. You know, no country. Germany decided to close down its nuclear power plants. There are only 2 reactors under construction in Europe, one in Finland and one in France. They have been under construction for several years now, way beyond what was originally planned, with the extra costs that are huge. So in Europe, the nuclear energy right now is, not on the agenda. But that is not the case around the world, because there are nuclear reactors under construction in several places, in particular in China and in a few other countries. As far as I know, in the Middle East, there has been some discussion, and forgive me if once again I refer to Saudi Arabia, because I know that Saudi Arabia and the United Arab Emirates have been planning to construct a nuclear power plant. I don't know whether they, still it is at the stage of discussion. And obviously here the idea is to be able to produce electricity without having to use oil. Because even in those countries that are oil rich, they understand that sooner or later oil will remain underground. Obviously, we do not know now. They want to do it very slowly relative to what perhaps other countries like, more aggressive on the climate front would like to, but they start to understand that there will be, a decrease in the demand for oil internationally. So they start preparing for the possibility of building some or having some nuclear energy in those countries. Clearly, in those countries, the type of reactions from the public opinion is very different from what we would have or we have in Italy. In Italy, we had 2 referendums whereby citizens refused or decided to exit to get away from nuclear energy. That would be inconceivable in those countries, or at least the ones I'm talking to. So it really did the type of political acceptability of nuclear energy is not an issue, or is less of an issue in certain countries relative to others. But as far as I know, they are still considering planning to understand where it is useful to put it, because we know that several conditions need to be satisfied. For instance, the availability of large amounts of water to cool the reactor and so on. So to know where to put it. I know that also plans are nuclear. There are plans for nuclear plants in Russia, and to some extent, I do not know much more, but to some extent, the issues that I just mentioned hold also for Russia, obviously. That's what I can say.
Thank you very much. Thank you very much. There are some other questions, but I suppose most of the questions were answered. And unless you want to answer this last question, most countries in the world have embarked on an energy transition under the dual influence of the realization that fossil fuels are a limited resource. However, long supplies might last, and more recently, the growing awareness that they are adversely impacting the planet's climate. But what does an energy transition actually entail? I mean, this would bring us back to the beginning of your lesson, and I suppose.
Well, I thought I illustrated what it entails an energy transition, but I said, you know, let me put it just in a single sentence. You can think of the future. Which future, when it is still unclear? As I saw, net zero emission has put a time tag, a time deadline, all right? But think of the end of the century, if you prefer, a situation where energy will come basically in two ways or in two forms: electricity, hydrogen, period. How? What does it entail? Well, it entails a radical, dramatic change. Whether we are going to be able to bring about it, how much money it is needed, which are the countries and the industry that will, you know, be successful, will rise, and which will be those that will fall, you know, is a matter of speculation, or we can discuss about that. And, you know, also political acceptability. But that is basically the bottom line.
Thank you very much, Marzio. Thank you very much, Professor Galeotti. This seminar was very enlightening to me, and I hope to all of our students and trainees. And what I liked the most is the fact that you described not only the perils of the challenges of the transition, but also the opportunities, in the sense that you clearly showed that there is a net benefit in the zero net transition and net zero transition, and it is something that will unleash very big potential to create jobs, to create new types of businesses. Think of all the consulting about how to use green energies, renewable energies, how to adapt our homes, our dwellings, in order to save energy. And that is providing new jobs, new types of activities. So think of that. And since you are already entrepreneurs, or you want to become entrepreneurs, think seriously that the renewable energy sector is a very engaging but also very promising sector in which to launch new initiatives. Thank you very much. This is the end of our seminar today, and it has been a pleasure to be with you. We will have the next seminar for certain in November. There might be one in October. We are still trying to define the organization of that, but you will be informed with due time. Thank you very much. Bye-bye.
Thank you.
Thank you, and bye.